Hi, this is Javier Livio. I am part of the CPSC 6138 mobile system and applications with Professor Alfredo Perez. And this is my final project, which is actually based in a POC, or a proof of concept. And MANO stands for Myoelectrically Actuated Neuro Orthosis. There is a need to provide neurorehabilitation services in an efficient and regular manner to the population of patients who are remote to centers of physical rehabilitation. Hence the idea of having a device that will go through the technology providing these services. And there are certain facts that allow me to be inspired to work on this, which is actually the idea came from my friend. His name is Roberto Duran. He is an engineer, a robotic engineer based in Canada, and he owns his own company. And those facts are that based on the 340 million people that live in the UA, in the United States, every year we have approximately 17,000 cases of a spinal cord injury. This is like a 14 cases per million. And the fact is that there is a need to assist those patients that don't have access to a physical therapy center, especially they are in remote areas. And our project called ARM, it uses a MYO, which is a Myo armband, and it's the one that will be guiding the physical therapy remotely if needed. So the application basically integrates this armband with a bioelectrical current generator for physical stimulation. Both devices are required for the application full functionality. This means without the hardware, this application won't run. And this is the flow of how the application works. From left to right, the patient have a paretic or no paretic arm, meaning the arm that suffered the damage or the arm that is no damage. The user will wear the armband, and the application, the one that I developed for this project, the Android application called MANO, will receive signal from the armband using Bluetooth low emission signals through the Bluetooth port, and that will be processed through an Arduino controller, which is the one that will receive the commands upon the application receiving signal for the armband. It will send that through the Arduino, and the Arduino will send the signal to the functional electrical stimulation device, the device that will be wearing the patient. In the next slide we will see that. These are the main two components, the component that will be connected or attached to the patient. The Myo armband specifically support the scope of the project, because it really what I did, I integrated hardware, this armband, with the Arduino through our application, so that the patient wearing the bioelectrical stimulator can receive a stimulation, electrical stimulation through the parameter that received from the Arduino. The application have a main or the master screen where the physical therapist can work and prepare to ascertain the patient condition. And this is done from this page. It's called the therapist home screen. From there, a therapist can input new patients, evaluate a patient by writing his evaluations, obviously, conditions, coordinate the therapies, and access both the Myo armband and the mobile device settings. Once the physical therapist is ready, he can access the armband activity center. There, from this screen, the Myo armband stage is rendered, meaning we will know when it's ready or not. If the device is ready, the patient can wear it, and the physical therapist can send signal or pin the armband so that the patient will know that is active and is connected with the application. Also, at that stage, the patient can start moving his arm or practicing the assessment and the therapy prescribed by the physical therapist. If for any reason on this screen the armband is not enabled or is undetected, the user has the option to scan and the application will look for the device. From the physical therapist's homepage or work homepage, he can also go to the work on the patient screen. And at that screen, he can proceed evaluating the patient by ascertaining his condition. He can define and select the therapies that the patient needs to recover, and also he can select the MANO operational mode, which are supervised or non-supervised. When it is supervised, the therapist can input his comments and change the assessment as the patient works on the therapy. When it's not supervised, there is no way that the patient can input or change any data based on the therapy prescribed by the physical therapist. Physical therapists have two stages. One where the therapist can define the assessments or see the diagnosis of what's going on with the patient. And here we can see how he defined one, and he can see all of those that he has written. And the same once the physical therapist has ascertained or determined the condition of the patient, he can go and now define the therapy or the intervention by inputting directions like, okay, flex the right arm and rotate the right arm and so on, and save them. From this point, when the patient logs in, he will see this instruction, and wearing the arm band, he will be able to start moving his arm, and the application will send stimulations or electrical signals through the armband and be processed by the Arduino controller, which will communicate with the electrical stimulator, allowing the patient to receive electrical physical therapy. Thank you very much.